what has happened so far in this module. So lesson one, oh, I'm jumping ahead. Lesson one was area and perimeter. Lesson two was basically volume and surface area of rectangular prisms, triangular prisms, and cylinders. And lesson one was circles, triangles, and rectangles. Lesson three was all about the volume of pyramids, cones, and spheres. And so what we're going to do today is we are going to talk about the surface area of these shapes. And then also what we're going to do is we're going to add some combo questions where we start to combine the shapes together, and possibly some old exam questions too. So that's the rough plan. So thinking back to the previous lesson, if you weren't here for that lesson, you will need to like sort of just watch extra carefully as we get going. Okay, give me a thumbs up if you remember that, and if you are ready to roll. Give me a thumbs down if you're like, what? That didn't ever happen. Where was I? Okay, so let us begin the journey then. So in the previous lesson, we started talking about this rather cool looking shape called a pyramid. And we spoke a little bit about the difference between something called the perpendicular height, which was really, really important for finding the volume. So in the previous lesson, we spoke about how the volume of a pyramid is just a third times the area of the base times the perpendicular height. However, there is also another height in a pyramid called the slant height. And the slant height is the height of the triangle on the outside. And often what we do is we refer to the slant height as S, the letter S, and we refer to this one over here as the letter H. Okay, so that's something that's important going forward today. Now, I want to know what the battle plan is. If I said to you, find me the surface area of this particular shape. So in this question, it says find the surface area of the pyramid with height like that and a square base with sides all 6 centimeters. So we actually looked at this question in a different way in the previous lesson, but basically, I want to know from everybody what they think what would their plan be, not the answer. What would their strategy be, or what do you think we need to do in order to find the surface area? What shapes are involved? Who would love to come online quickly? Just give us a suggestion. What do you think we need to do? Okay, so Chinolo used Pythagoras. What would you use Pythagoras for? For the slant height. So Chinolo is recommending that we figure out this thing over here called the slant height using Pythagoras. Why do we need the slant height? Who would like to tell me why is the slant height important for this question? I don't have it, you're right. But why is it important? Let me pop your hand up if you're feeling like this is your time to shine, guys.
Come on, guys.
Don't worry. I know it is a bit strange, but even if you get it wrong, getting it wrong or getting it right has equal value to the class, as strange as that sounds. Because even if you make a mistake, seeing the answer straight away afterwards helps you. So what I want to know from the class is, why is the slant height important for finding the surface area, where surface area is basically, if we had to wrap the whole thing in wrapping paper, how much wrapping paper would we need? Nolotando, yes, let's go to you.
Hi, sir.
Hello.
So don't you need the slant height to find the value of AC, that line?
Yes, you absolutely do. But why would it be important for this question?
For finding the area of a triangle.
Exactly. That is exactly it. If you don't have that, you won't be able to find the area of the triangle. And there's 4 triangles around the outside. So that's exactly it. Thank you, Nono Tando. I just wanted to check that students knew that. Okay, let's try and find the slant height. So if somebody needs to find me the slant height using Pythagoras, well, I think another important step is going to be, what is the length of BC? So if we look at BC, I want to suggest it's 3 because I know the whole way across is 6. So this is 3, that's 3 root 2. What is this S over here going to be, the slant height? And I would love for somebody to put the slant height in the chat. What are you getting for your slant height? We are going to use Pythagoras. And we can do that because it's a right angle triangle. I'll give you a bit of time to work that out. So for Pythagoras, we know that the hypotenuse squared is equal to the other two sides squared. So, well, the way I would do it is you go 3 root 2 squared plus 3 squared. And I've used the shortened form. Let's see what we get. Pop your answer in the chat. What are you guys getting? So we're going to get, so it should be square root 27. So I get 5.19, or if you left it as a third, it could be square root 27. Or another way of writing that would be 3 root 3. And given a choice, you know what, guys, this is where the better thing to do is actually just to leave it in third form. So, or even square root 27, because this doesn't lose the decimal places. Whereas if you use that, you're cutting off some of it. So both of these will be correct. But if you're going to use them in a later calculation, I would use the third. Okay, so now the question is, what is the battle plan? I want to suggest that there are 4 triangles and 1 square on the outside of the shape. You know what the height of the triangle is. It's going to be, I'll just say square root 27. Please work out for me the surface area of this whole shape. I want to see, can you get that? And then I'll pop the answer up in a moment. So it's definitely the case that surface area is a bit trickier than volume. It takes a bit more planning, but the good news is once you've got your plan, you can kind of reuse it. So think about where the base of the triangle is. So I see the base of the triangle here. And I see the height of the triangle there. And then I also see that same thing repeating 4 times over. And then I also see there's a square that needs to come with that. See what you can get for that surface area. And yeah, while we're working on this question, if you have a question, pop your hand up and I'd love to have a chat about this. Okay, so I see Letu has an answer that's coming through there. So as answers are starting to come through, I know the area of one triangle will be a half times 6 times square root 27. So that would give me one triangle, but I have 4 of them. So I'm going to go 4 times that. Plus, I can't forget that there's a square on the bottom, which is 6 times 6 for the area of a square. So let's see what we get. 0.5 times 4 times 6 times. So we get 36 root 3 plus 36. You should be getting in total. Okay, some of you are getting the total without the 36. So don't forget, you need to add that there. So 2 times. So this part over here gives you 62.35, but you have to add your 36. So what's my final answer going to be? Aha, swap. I think you are on the right track. It's going to be 98.35. And this is going to be, it's in terms of the units. I think it was centimeters, so it would be centimeters squared. So what is the main goal of this first question of the day? It's to give you a battle plan for working out the surface area of a pyramid. And the good news is it's just 4 triangles plus the area of the base. Now remember, a pyramid can have different types of bases, but you're always going to have, well, it's not always, in fact, always going to be 4 triangles. It's going to be the number of triangles going around the outside of the shape, however many sides the shape has, plus the area of the base. But the slant height is important to find the area on the outside. Okay, so that was a good first example of the day. And I want you to take a screenshot now if you need to, just to look over it. We need to do another example like this. And that will help us through this process. So just take a screenshot now if you need to. Just a quick vote. Thumbs up if you feel like you sort of get this. Thumbs down if it's still very early on for you. It just helps me gauge what the atmosphere of the class is like. Okay. So here is the next question. Similar type of idea, except, well, I'll let you read the question. Find the surface area of the following square-based pyramid. See if you can use whatever is in the drawing to help you find the surface area of this square-based pyramid. And just take the ideas from last time. What is the battle plan that you can use? And if you are stuck, then remember you have the lovely Lebo in the chat who is willing to help, or you can even raise your hand and we can have a little chat. And I know this is a bit strange. I mean, a lot of you haven't seen pyramids before, you haven't worked with them. So yeah, take the time, invest in yourself and ask a question.
Mr. Ace?
Yeah.
Will they be given the formulas in a formula sheet, or would they just have to memorize these?
Okay, so generally speaking, in the exam, you are given formulas, but a lot of the time, so it depends. They have to be able to interpret and know where the formulas come from. So they'll see in the old exam question we do later, they often do give you parts of the formulas. They don't give you like the fact that the area of a square is side times side, or that the triangle is a half base times height. So in this scenario, the surface area, you kind of have to, if they give it to you, you kind of have to understand how it's put together. That's maybe the best way I can describe it. The volume formulas, they definitely give you. The surface area formulas, they do give you, but you have to be able to understand where they've come from. So I guess that's the, yeah. So you are, in
Thanks,
summary,
Mr.
that you
S.
are
Because
given
there's
it.
a question from, yes, Bitumela was asking what the formula for surface area is.
Okay, the problem is there's different types of pyramids. And so because there's different types of pyramids, I can't give you a formula. All I can tell you is it's whatever well, I can give you this formula. It's the area of the base, but that base could be different shapes, plus it's the area of all the triangles on that base. But the number of triangles depends on how many sides there are on that base. The good news is it's almost always a square or a triangle or something like that. Okay, so what are we getting for the surface area here?
Thanks, Mr. S.
Pleasure. Half base times height. So half the base to me looks like 13.2. And they've been so friendly. They've given me the slant height. How nice of them. Now, that's the area of one triangle, but we have 4. So I times it by 4, plus the area of the square is just 13.2 times 13.2. So what do we have as our final answer? What I get is 765.6 centimeters squared. Level is asking a very good question, and it's going to come up in the next question too. Sometimes they will give you a formula because there's so many different variations. They will give you a formula for a shape, and it may look a bit different to what you're used to if you haven't seen that shape before, but you want to think back to the beginning and go, what is this made up of? How many different pieces are there? And then you'll be able to understand what that formula is used for. And so that's why I'm almost forcing you to build your own formulas here. But you always in the section get, so are we supposed to use the slant height instead of the perpendicular height? Kevin, this is a fantastic question. In the case of volume, in volume, they will give you a formula which says 1/3 times the area of the base times height. That h is the perpendicular height. So for volume, the perpendicular height is the important one. However, when you are dealing with surface area, then it is the slant height or the height of the triangle on the outside that is the more important. And then you may see an S popping up in a formula. And so the answer is it depends on the question. But I hope that I've given you some awareness about where the S will come in versus when the H will come in. And the reason they call it S is because it would get confusing if we had two heights. So it's on a slant height. So there's the question there. Okay, let's go on to this one over here. Now, I'm going to give you a formula like they would in the exam, and you guys are going to work out how to use it. So this is the shape of a cone. The formula for the surface area of the cone is pi r squared plus pi r s. So before we start this, I want a little discussion or a little comment from the class. What do we think these pieces of the formula? That is the formula for the area of a cone. Like, there's no debate. It will be given to you in the exam. I mean, you can derive it using fancy maths, but it is true. What I want to know from you is what parts do you think, like what part do you think this relates to? What part do you think this relates to? And what is this funny S thing over here? So I'd love someone, if someone's brave enough to just maybe tell us one part of that, or tell us what they think. Can they see how that's connected? Yeah, Hendrina, let's go to you. Hendrina, what part?
So
Hey.
The pi r squared is to find the area of the base, and
Okay.
I think the pi r
Yes.
And the pi rs is to find the area of the, to use the circumference to find the area of the cone part.
Yeah, it's like the curvy part, hey?
Yes.
Exactly. And so, and then the S, what do you think the S stands for?
The slant height. I
Perfect.
think.
Yes. So a cone also has what's called a slant height. So, and this is typically what would sort of be given in an exam. But sometimes if students haven't gone through this process of breaking the shapes down, they kind of feel like, why are there so many R's and S's and what's going on? I want you to have a go at trying to find the surface area of this cone for me. So you're given the formula, find me the area of this cone. Oh, sorry, I've left one thing out. I think I've left one thing out of the formula to see if I have. No. Pi r s. No, I'm right. Pi r squared plus pi r s. Oops. I just had a moment where I had to be like, am I telling you the truth? And the good news is I am. Even teachers have those moments. Of course they do. I like to leave a space for things that I have to fill in. So I'm kind of like, I know that's what I have to fill in. The problem is I don't have this thing. And it feels like I need it. What does Pythagoras say? It says, so what I get is I get 4 root 5 for my height. You could also write it as, what's it, 64 plus 16. So it could be also the square root of, I suppose, 82, but 4 root 5 will do. And so we know, actually, what would I rather leave it as? So 8 squared is 64 plus 16. You could also leave it, actually, it's easier to leave it as square root 80, now that I think about it. Like, that's the easiest way to have it in the calculator. So I would make that square root 80. And then this has to be 4, and that has to be 4 because it's the radius. So what are we going to get for my final answer? It could be in terms of pi, or it could be in terms of decimals. So you'll get 16 pi for the first bit plus pi times 4 times root 80. And you should get 162.66 centimeters squared. If you had it in terms of pi, that is also fine. It just depends on what the question is. Okay, so the good news is, yeah, they give you these formulas in the exam. All you need to know is a common variation would be to say, find the surface area of the curved part of the cone. Now, if they say find the curved part of the cone, you have to have the understanding to know the bottom circle is not curved, so that means ignore that part. Whereas if it says find the surface area of the whole cone, it's going to be those two parts. So just to show you how understanding how the formula is put together is useful.
Mr. S?
Yeah.
Before you move on, there's a question in the chat. Can you please explain how you got root 80?
Okay. So if you look at using Pythagoras, that is the step over here. And what I realized is I needed to use the h in this part of the calculation. And all I said was 8 squared is 64. And 4 squared is 16. So really, I could actually just leave my answer as square root 80, which is quite easy to type in my calculator. Whereas if it's like 4 root 5 or whatever it was, it's a bit harder to type in my calculator. It isn't wrong though. You could also have gone square root 80 and used the decimal, which is 8.94 and so on. It means like you're having to carry the answers forward. And I think that leaving it in the surd form is an easier way to carry it forward, basically, is what I would recommend. So Mokhlodi, I think what happened was the rounding. You took your figure here of 8.94 and you used it in here. Now, depending on how the question is phrased, you shouldn't really be too heavily penalized or penalized at all for that. But as a general rule, if you're moving forward in the question and you're not required to give the answer H to 2 decimal places, it's probably better to use the height in surd form because it carries all the decimal places with it. Okay, I hope that helps a little bit. It's not wrong using 8.94. It just means that it will take you longer to type it out. Okay, awesome. I think we need to invest in ourselves and have a stretch. So I want to see everybody on their feet. I want you standing up. I want you to just check that you still have some feet and that they're still touching the ground, that you haven't started spontaneously floating. And oh, I think I'm going to do a calf stretch. That's going to be me. So do your favorite stretch. And I've been doing this a while now, guys, and I can tell you the students who do the stretching, they feel better. They come back second half and they're ready to roll.
Yes,
so take the
we
time
get
out.
energized.
Get energized, yeah. We're not made to sit all day. Like, it's just not how our bodies were designed.
Yeah. Rachel is getting into that stretch.
Oh, it feels so
Sarah,
good. There we go.
come
Oh, that
on,
is-
guys.
There we go.
Mason, yes.
Good. Oh, I can't tell you how much better my body feels. Oh, absolutely. I think we should make that mandatory. There should just be like a ballet school. Every half an hour, everyone has to get up and stretch.
Yes.
Help everything else. Okay. What I want to do is a brain break, but the brain break is a little bit more sneaky today. So I will give you a clue because otherwise it might be take a little bit too much time. So the brain break is like before, we're trying to find the missing pieces, but there's multiple kind of ways the equation can be true. And the hint I want to give you is that what are the possible whole numbers that when multiplied together give you 14? That would be a good place to start. Like, ask yourself what are possible, and if you had to choose one of those combinations, which combinations would work best with maybe doing something like getting that thing to work out. So take a moment to just get familiar. But my main hint is the green one. What a rocket times an eagle is 14. What are the different possible whole numbers that give you, so a lot of people are saying 7 and 2. And so I want to suggest, why don't we try 7? Now, it could be wrong or it could be right, but I'm going to put 7 and 2 here. And if we assume that to be true, see if you can work out what the other pieces are, and then eventually figure out what this is. Okay, so remember it's a times over here on the vertical and a plus on the one on the left. Oh. So I see a couple of people have said this could be 20 because 20 times 2 is 40. Oh, and some of you are jumping. Tandeka, let's have a look here. Tandeka, what do you think? I'll unmute you here. Or did you hit the wrong button there? Tandeka, what do you think? So I agree that this little man or woman looks like a 25. Now, have we got everything? Oh, it works because 25 plus 7 is 32. Rocket is 7. Okay, what's my final answer going to be? Astronaut is 25. Yes, Boitemelo, I agree. What's the final? So the eagle we said at the beginning was 25, so that's 50. The moon is worth 20. And Lenovo and Dile, I agree with you. This is going to be 30. Yeah, you guys are fast. So, yeah, that was a little bit harder than the average equation puzzle, but I liked it. I liked that there was more thinking involved. Just give us a quick, if you thought tonight's puzzle was a little bit too hard, give us a thumbs down. If you liked the puzzle, give us a thumbs up. Because I'm looking to branch out in terms of what our puzzle life is like.
Puzzle life.
Yeah. But let's take it up a notch. Okay, that's good to know. Well, Monique, it was a little bit easy because I gave you that first hint. However, if I hadn't given you that first hint, which may happen in future lessons, then it gets a bit trickier. Yeah. No, that was a tough one because there's equations going up and equations going to the side. So I thought that was tough. The first time I saw it, I found it tough. Okay, let's get back to our lesson. So what we're now going to do, I think we've done that one over there. So I just want to do a quick little, I want to run you through. So the sphere is a funny one. And again, they give you the formula. So if you look here, the surface area of a sphere, and this will be given to you, is just 4 pi r squared. So please find me the surface area of this lovely looking sphere over here. Just check that you know how to work it out. Typically, spheres are asked as part of another shape. So very rarely do you get asked about a sphere by itself. It's normally tacked on like as an ice cream cone or something like that. But then you need to know how to work with it. But let's just do one question. Find me the surface area of a sphere. So we know the formula has got a 4 pi. We know there's a square. Now, what is the radius? The radius here is 7. And just to point out, in a sphere, the radius, there was a good question, I think, from Kevin in the last lesson about like the radius. The thing about a sphere is that the radius is the same distance in every single direction to get to the edge. And so that can be quite useful when you start putting spheres together with shapes. Okay, what do we get here? We're going to get 4 times 39. So it's going to be 196 pi, or as decimal, it's going to be 615.75, and we'll say meters squared. Okay, so what's interesting to know here is that, like, if you have a basketball or a soccer ball, although basketball is more perfectly spherical, all you need to know is to know the radius. Once you've measured the radius of your basketball, or I suppose you could measure the diameter and divide it by 2, you can work out how much material you need to stretch around the outside of a ball. So remember, like, a surface area is, I always think of wrapping paper. Like, if you have to wrap it up, how much sort of surface area do you need to go around it? And for a sphere, all that you need is the r, the radius. The rest is, the maths does the work for you. Okay, fantastic. Okay, you knew this was coming. So, time for combo questions. So, I will give you the formulas like they would give it to you in the exam. So, they will say the surface area of a cone is pi r squared plus pi r s. The surface area of a sphere is 4 pi r squared. I want you to try and work out the surface area of this rather special shape that is a combination of those two formulas. And I'm happy to take questions. I'm happy to have a discussion, but I just want to see if you can maybe think about some of the ideas we've learned about today so far. And what parts do we need to grab? What parts do we need to leave out? What modifications do we need to make? I love this question. It's a lovely combination of ideas from earlier on. And ask yourself, what's your plan? What plan do you have? I'll give you a bit of time for that. Okay, so Shane has put his plan in the chat, and I'm going to read it out because I think he's onto something here. Calculate the slant height to figure out the cone surface area. Then calculate the sphere surface area and divide it by 2, and then add them together. I like what you're doing with that. So first of all, we need the slant height, and the slant height would use Pythagoras, and we would go 10 squared plus 3.5 squared. Now, if you're unsure as to how I'm getting this, remember, you can write it out the long way with Pythagoras. That's not wrong. I'm just using the shortcut. So, s squared equals 10 squared plus 3.5 squared. I've just jumped the step where I get the s all by itself. And according to this, 100 squared plus. Okay, so this is where you need to make a choice as to how this is basically going to be. Let's have a look. 10 squared. I would just write it in the way that's easiest. In my calculator, it's writing it as the square root of 449 over 2. Or as a decimal, it would be 10.59, blah, blah, blah. But I'm probably going to use this because it's probably going to be easier to work with later. So let's have a look at what we need to do. So we know that the area of the hemisphere is 4 pi r squared. But the problem is we only want half of that. And so I'm going to divide that by 2. My radius was 3.5. So this is what Kevin was saying. Who was it? Was it Kevin? So I'll keep the answers coming. We don't know what the correct answer is yet. Sorry, it was Shane. And so that's basically this part taken care of. Now, in order to get, that's this bit up here. But because we want the pi rs part, we go pi, the r is still going to be 3.5, and then the s is going to be this bit here, or what I said was. So let's see what I get for my, well, in fact, I've got the final answer below here, so let me pull that up. I'll save some time. Keep those answers coming, everyone. Okay, so watch out. A half times that. Where everyone's getting 231 pi rs. So pi rs, 4 pi r squared divided by 2. Did you forget the dividing by 2, maybe, guys? Okay, because I have a look there. We've almost got it, but I just want to make sure. Some of you may have got caught out by some part of it. So pi rs, let's have a look, because we are getting harder now, so we need to slow down a little bit. So the S is the slant height. I got that. And that's this bit over here. The 4 pi r squared couldn't stay the same. It had to be divided by 2 because there was only half. This bit here is not exposed. It's covered. So it's not on the outside of the shape. Okay. So let's just take a moment. I'd love some questions from the class. If you understand where you went wrong, let me know in the chats. What I'm getting, according to the answers here, is we should be getting, there might be some minor rounding differences, which is okay, but you should be getting somewhere around 193. Why is this square rooted? So this is the, okay, so we could have also put here 10.59, which is the, it's basically this thing here. It's the slant height of the shape up here. Yeah, see how, let's go to you.
Hi, sir.
Hey.
So I have a question of why did we ignore the pi r squared in the surface in the formula for the surface area of the cone?
Why do we ignore the pi r squared? That is a fantastic question. Okay, can you see the shape here? Can you see this? The circle bit is actually covered by the cone. So can you see that the cone is sitting on top of it? It's almost like not letting it see the outside world. Does that make sense? This is what we call a compound shape, where we put the two shapes together. And so that's why I had to modify the formula, because I wanted half of a sphere. That's why the divided by 2. And I wanted only the curved part of the cone.
Oh.
Where did I get the 10.59 from? In my formula for the cone, can you see that I need the slant height? I need the S part. So I didn't use, in order to find this curved bit around here, this relates to the pi r S part here. And so when I worked out S, the slant height of the cone, it was 10.59. That's why it's over here. Okay, but it's getting tricky now. Like we're up to like proper exam level questions now. Like, so I wanted to make sure you saw the harder ones. They're not always as hard as this, but I thought it would be good for you to see something. Now, I don't expect you to be 100% comfortable about this one, but if you come back to it later and watch it again, I think you'll see some of the pieces come together. Are there any questions and comments from the class before I move on to another one? Bokang, let's go to you.
Afternoon, sir.
Hey, how's it going?
Good. I wanted to ask, so when do we divide by 2?
Okay. You divide by 2 if you've got what's called a hemisphere. So it's not a whole sphere. It's almost like you cut your basketball in half. Can you see that in this shape, it's not a whole sphere? It's just that part there. But the circle on top of the hemisphere is covered. So that is not exposed to the outside world. So it's not on the outside. Does that help a little bit, Bokang? So that's why I had to take the formula for a whole sphere and divide it by 2, because I only had a half in my question. Yes, so Kevin, what we do is we leave out the area of the circle, because it's not on the outside of the shape. And so this is what I meant by, in the exam, they will give you the formulas for the whole shape. But if you have to get two shapes together, and again, this is probably harder than most questions will be in this section, but you need to know how to take a formula and adapt it if they stick two things together.
Okay, so like in a test, when should we know like we should like divide it by 2?
If it's half a sphere, if it's half of it, basically, if it's been chopped in half, if you see the whole sphere, like if you see this, then you wouldn't chop it in half for this one because you see the whole sphere. But the moment you chopped it in half, you needed half the surface area. Okay.
Oh, okay, I get it now.
Yeah. Okay, let's try one more question. This is from an old exam paper. And again, guys, I don't want you to be overly stressed. I want you to see kind of like you're working towards this, right? You're not quite there yet. Now, in this question, I'm going to read through it with you, and then you're going to work it out together. It concerns what type of shape? It concerns a pyramid. But what you'll notice is that it's not a compound shape. It's just a normal old pyramid. But what this question is about is it involves volume at the beginning. They actually give you the volume. But in the question, they ask you to find the perpendicular height. Okay? And then at the very end, they ask you to find the total surface area of the pyramid. Now, this is from an old exam paper. So what I want to do first is I want us to try and look at this question. And I just want some suggestions from the class as to how we would go about solving it. So let's read it together. A pyramid with a square base has a side length of 16 centimeters. P lies on the square directly below A. The volume of the pyramid is 640 centimeters cubed. The volume of the pyramid is given by the formula 1/3 times the area of the base times the height. Okay, so they've given you all this information, and what's different about this is that they're throwing a lot more information together at you. They say, show the perpendicular height of the pyramid AP is 7.5 centimeters. So you have to show them that. Now, first of all, whenever I get a question like this, I go and draw on my drawing. I make sure I know where these things are. So where is the perpendicular height? The perpendicular height is here. Where is A? And that's what we're trying to find. What do we need to work out in order to find what AP is? Who would like to give me a suggestion before I really get going? Who has an idea or a strategy that maybe we could use? What do we have already? What do we wish we had? Like, do we know what PT is? Do we know what AT is? Buchle has said the base. Okay, so Bongeka has said, I'll divide 16 to get 8. So Bongeka is saying, you can work out that this is 8. Letu has said, we need to figure out what AT is. And then Nolotando has said, if we work out what AT is, we can use Pythagoras. Okay. I think the big problem is, how do we work out the slant height? I think the formula could help us, because we really need to work out what AT is. So what I'm going to suggest is, can't we put something into this formula? Or maybe we could just use the formula. Yes, Bongeka, I think you're right. So let's just go 640 is the volume, equals 1/3. Do we know what the area of the base is? Well, the area of the base was a square. And so isn't this going to be 16 times 16? Aha. Yes. Okay, I like where we're going with this. So check for yourself. What do you get for h if you move this whole thing to the other side? What do you get for h? Let's check. So I'm just going to go fraction 640 divided by 1/3 times 16 times 16. And what do you guys get? I get 15/2. Okay, so okay, if you go 60, maybe we should do the intermediate step. So maybe what we need to do, what is a third time? So we go a third times 16 times 16. Okay, that also gets us a messy fraction like 256.3h. Okay, so what I was hoping that you would find, guys, is that when you bring all of this stuff to the other side, so basically you divide by this whole thing, you should be getting that h is 15/2, which is 7.5, which is what they asked it. So what I want to show you is that even though it looks a little bit different, it's still using the same ideas we've been learning about in this particular topic. So now for the last question of the day, I want you to find me the surface area of this whole pyramid. So find me the surface area of this whole pyramid. And you'll notice they haven't actually given you any formula for that. They gave you a formula for the volume, and you had to use it to help you find something. But now you're on your own. You need to think, how would I find the surface area? And Bukle, you're on fire today. So Bukle is throwing out tips here. You need to use Pythagoras to find the slant height. I think you do too. Yeah. I think that would be helpful. Yeah, you guys are doing well. Like we've got to proper questions now. Like we've been sort of turning up the heat gradually. And then I'm like, before you know it, like I'm sticking spheres on top of pyramids, on top of who knows what's. And then so how would we work out? We'll call it AT. I know I have 8. And we know the height is that. We should give a reason. So yeah, there's 2 ways you can write this. I'm just going to write it as 481. My calculator is just saying this. It looks a bit weird, but it's helpful. Now, what is my surface area going to be? So I know that I have a square at the bottom, and the area of a square is 16 times 16. I know that I have 4 triangles, and each of those triangles is going to be a half times 16 times this thing, which I know looks a bit weird. And that should give me my final answer. So let's see what we get. And don't be afraid to use your fraction button here. Otherwise, you're going to get into trouble. 481/2. And we should be getting, and there will, depending on how many decimal places you use here, there'll be a slight difference, but 606.91 centimeters squared. So basically there'd be 606 or almost 607 little squares of 1 centimeter by 1 centimeter around the outside to cover the surface area of the shape. Okay, so I did push you guys today. If you are new, then you may have found the pace a little bit much, but again, we had built up to this. And again, remember the one thing about Watobe is you can go back and watch just a short part of the lesson again. So maybe you just need a recap of like a little part of the lesson. Sometimes your brain needs some time to digest. And so just remember, you can always rewatch these. But yeah, I'm very impressed by how you have done today. Lebo, if you could just pop the link to the quiz in the chat for the students. And yeah, we will, this was basically just trying to give you a fundamental base for measurement. I would still say doing old exam questions and practicing will help you. But yeah, I really think we've built a nice foundation for you to achieve even further in this section. Okay. Once you are, if you don't have any more questions, then I'm going to invite you to go off and take the quiz and just see how that goes. And yeah, I will see you all again on Monday. If you have any final questions, I'm around for a little bit more time. You can pop your hand up and I will do what I can for you. But the rest of you, yeah, enjoy the rest of your evening. And yeah, well done for working hard and taking responsibility for your maths. Are there any questions from the people of the class? All right. Lebo, is there anything from your side? Oh, my alarm is turning off. Hey Siri, turn off the alarm. Sorry.
No,
I've got one of these fancy speakers.
From my side, mistake. Oh.
So like, you know, like they turn it off and on and yeah, anyway,
Yeah.
it's quite cool. Okay, cheers everyone. Cheers Lebo. Thank you so much for your help today.
Guys.
I will see you next week.
Always great working with you, Mr. Ace.
Pleasure, Lebo. Likewise. Okay, class is dismissed. Or